Good evening. Good night. My watch doesn't understand that, sorry. Are we all in the right place? Yeah. Thank you all for sticking around until the end of the day. My name is Paul Andrew, and we are here to talk about creating a metadata-driven... What are we here to talk about? Oh, yeah. No. Sorry, it has been a long day, as you can tell. We're here to talk about creating a metadata-driven orchestration framework using Azure data integration pipelines. And my name is Paul Andrew. So data integration pipelines, what's that then? That's just something that I've made up. But of course, Microsoft have done their usual trick of adding more things, abstracting more things. So once upon a time, we had a lovely service called Azure Data Factory. Who likes Azure Data Factory? Good. Yeah, we're among friends. We can admit this. We like Azure Data Factory. And then, of course, now we have Synapse Analytics as well, right? And we have integration pipelines in Synapse Analytics as well. So when we go into the Synapse Studio, we have the Integrate Hub, which has got a little pipeline icon next to it. So I've taken, apparently we need some more volume, folks. More volume? They can do that, not me. Can you hear me now? Good? A little bit? Testing, testing? Awesome, thanks. So, of course, we now have pipelines available in Synapse Analytics. We have pipelines available in Azure Data Factory. So I've just called this very holistically integration pipelines. So what we're going to talk about with this title and with this slide is pipelines either in Azure Synapse Analytics or in Data Factory. We can be very interchangeable with those terms. Good stuff. So the slides I'm about to show you, if you would like to take a PDF of them, there is already a PDF of the slide deck in my GitHub repository, the community events one. There's a subfolder in there for SQL Bits 2022, so feel free to go and grab that one. So you can see all of the pretty things that I'm about to show you. We all good? Awesome. So let's just break down our agenda and let's just have a really, really quick recap of Azure Data Factory. I assume everybody in here has been using Azure Data Factory for a while now. I appreciate I've got a good, reasonable audience in the room, but I've probably got some people online as well. So we'll have a quick recap of Azure Data Factory. And this is how we'll just talk about it and introduce it. So we've got a baseline for what we're then going to talk about next. So Azure Data Factory, or Azure Synapse Analytics pipelines. It's an orchestrator. We'll start by calling it an orchestrator, and it will orchestrate at a control flow level a process of getting some data from A to B to C, whatever we want. And we create these logical pipelines as wrappers around those processes. And the things that we'll need to build in our Azure Data Factory to do that, 5 things. Number one, our link services, something that Data Factory needs to authenticate, to communicate, to interact with another service out there in the wilderness, whatever it may be. There's, I think, 100 or so now link services available for Azure Data Factory, so it can talk to a lot of stuff. We have our data sets, number 2. Data sets are a metadata representation of the things that we want to work with. If this was a SQL database table, we would have a data set for the table. It would have information about the schema, the attributes, the data types, the contents of that thing that we want to work with. And our data sets will authenticate using our link services, number 1. We then have this thing called an activity. So in my very simplistic view of getting some data, the activities are there as the bespoke information for the service, the resource, the thing that we want to go and invoke or interact with. So if this was a Databricks notebook, we would have an activity for that. It would give us options about the workspace it was going to talk to, the notebook name, the parameters we want to pass to it, some libraries that we want to give it for its execution. Our activities could also use our link services to authenticate with something else out there in the wilderness if they needed to. We then have our pipelines, of course, the main event, the main thing that we want. And as I've got with those dotted lines in my picture, the pipelines are these wrappers of activities, the containers, if you like, the things that are going to do the work that we can then add our activities into. We can add many activities. Up to 40 activities is the current limit for the pipelines. Then lastly, number 5, we have our triggers. So the way in which we are going to tell the pipeline to run, to execute. These triggers come in a few different flavors. We can, of course, run the pipelines manually from the Data Factory Studio, programmatically with PowerShell, with the .NET SDK. We can trigger the pipelines using what's called a tumbling window. So inherited from Data Factory version 1, which was then called time slicers. Very good for working with time series data. We can trigger our pipelines in a scheduled way, very much like our SQL Server agent, doing something very iteratively at an interval of daily, weekly, monthly, whatever, until a particular end date. We can now also trigger our pipelines based on events of a file being created or deleted in our blob storage. We can also subscribe now to any topic from an Azure event grid. So it helps us creating a very event-driven architecture for these pipeline executions if we want to. Okay? So that's a very quick introduction to Data Factory, the components that we want to create, we might need within it if we're doing something with our data in a very sort of typical data engineering type way. Now, the good thing about Data Factory, and if we think of it as an orchestrator, and if we labor the metaphor, we could say Data Factory's hymn sheet is JSON. Everything underneath, everything that we build with those 5 components is JSON artifacts that will go into our source code repository. Now, the great thing about that is that that JSON, that content, can all be dynamic, apart from our triggers. But everything else, we can add expressions, add parameters, add variables. We can make all of that content dynamic as we want it at runtime. Okay. So, quick introduction, quick recap of our Data Factory. So, if we then pivot and turn our attention to the main thing that I want to talk about in this session, is a simple problem. A simple problem of, well, if we've got lots of these pipelines, how do we structure them? How do we structure them within a data factory or within many data factories? So if I put something on screen a little bit like this, it looks a bit washed out on the screen there. There is actually a world map underneath, a world map of the Azure regions. Trust me, it's there. But how do we structure all of these pipelines that we have all around the world in all of these different regions potentially? So it's a problem that we seem to come across, or I seem to come across quite a lot. And I asked my 3-year-old daughter, I said, how should we structure these pipelines? She said, like a dinosaur, Daddy. I said, yeah, okay. We can structure them like a dinosaur if we want, but of course this doesn't really help us. And but the wisdom of a 3-year-old, like a dinosaur. So if we think about that problem a little more, going into a little more detail of, well, what we're actually talking about, that picture looks really washed out. There are some grey boxes around some of those things as well, certainly on my screen. But we have some data, it's very similar to my introduction slide. I've got a landing zone here, I've got a cleaned zone, a transform zone, a serving layer, whatever this may be. The labels of these layers of our solution, not important, but just to make the point. So we have that in our storage, potentially, our data lake, maybe. And we have our orchestration service. And we create 3 pipelines. We have 3 data sets, maybe 3 business processes, who knows, whatever. Just an example. And we want to take that data through the layers of this solution to enrich it, to curate it, to get insight from this data, maybe. So we create some activities within our pipelines. We do some copying, we run a Databricks notebook, we run some Azure Functions, maybe. Who knows, whatever the requirements are. And in that scenario, what we could say is that we execute those activities in horizontal processing planes. So from start to finish, everything is nicely linked together. We can control what happens based on that horizontal view for a given data set or a given business process. But of course, we go further with the evolution of our solution and we end up with a dependency. A dependency between, in this case, the first data set in pipeline 2 and then the notebook that happens for pipeline 1. Maybe it's a fact table, maybe we've got some foreign keys that we need to resolve or something, whatever. So it means that those horizontal processing planes aren't going to work. We can't keep them isolated, we have to join them in some way because of that dependency that now exists. So we say, fine, we can work around it. We deploy 3 new pipelines. We call them A, B, and C. And we say that now we're going to address this by having vertical processing planes. Fine, we could do that. That could work. We process everything for pipeline A to get us from landing to cleaned, et cetera, et cetera. Okay, that's fine. But, of course, we end up with another dependency, which breaks that model again. So that doesn't work for us. So we have a rethink, and we say, okay, I'm going to go super granular with what I need to do now. I'm going to have 1 pipeline per activity. Crazy, right? But we could do this, and we could then join everything according to its dependencies, and maybe we come up with some wrapper that says, I've got a parent pipeline here that handles all of those child objects in there with that dependency linking as required. And this could also work. Not very efficient, not great, not easy to debug, not very dynamic. And very quickly you will hit that limit that I referred to earlier, 40 activities per pipeline. Which means whether these are child pipelines or whether these are all just activities within the same pipeline, we're still going to hit this problem. And I'm obviously only just talking about this for a few layers of a solution and a few data sets. So maybe we have a rethink, maybe we do some refactoring, we could. Maybe we consolidate some of those workloads and we come up with a working definition that says, fine, for those child pipelines, we'll have them at the lowest grain because we need to support some dependencies. We have consolidated work in a parent pipeline where we don't need to worry about a dependency. We can just get that work together, and we have the grandparent as the bootstrap of all of this. And again, this could work. We might do this, but it suffers the same problems. Difficult to manage, difficult to deploy maybe, doesn't handle very well in terms of failures, restartability, all of this stuff. So, all of this stuff, the problem of executing those pipelines and structuring them, but, at this level. So the solution I want to put to you, the point of this talk, of course. And this solution is simply to use metadata to drive our data factory pipelines, or indeed our Synapse pipelines. Now, this solution of using metadata to drive our processing, I'm not inventing the wheel here. We've been doing this for many, many years with sys packages, with store procedures, with whatever else. So no new concepts here, just new technology. Same problems, different technology. So we use metadata to drive our processing. And in my case, I would store that metadata in an Azure SQL database or any flavor of SQL database, hosted or otherwise. And we can then use that metadata to drive a more complex hierarchy of pipelines. So if we think about that against our problem statement, as I've described it, we've got all of those activities. We need to structure them. We need to join them together in some way. We bring in our metadata and we introduce the idea of execution stages. And when I say execution stages, I mean for those vertical boundaries that I described with this dependency chain. I call those stages 1, 2, and 3. For the horizontal processing planes, I say, okay, fine, we've got pipelines A, B, C, D to, what have I got on the slide, to I here. And then, did you know you can do something really complicated in a SQL database? You can join two tables together. Amazing, right? So we do that. We join our two tables together using some magic, and we come up with our execution order, basically. Stage 1 will process pipelines A, B, C. Stage 2 processes the next set of pipelines, etc., etc. So then the table that we've got joined becomes the run order. It addresses this problem of dependencies. And we can say that we've then got these hard boundaries between those execution stages. We say that everything in stage 1 must complete before stage 2 can run. And we use those hard boundaries to drive the dependencies that we need for our process, for whatever that process may be. Now, there is one more problem that we need to address if we consider that as an option, if we consider that when we're making things dynamic. And that one more problem, or that one more irritation, is that the call child pipeline or the execute pipeline activity within our data factory cannot be dynamic. So where I told you at the beginning that all these things can have lots of variables and parameters, sadly, not this one. It uses reference names internally to the resource. It uses reference names which mean it has internal dependencies, which means that when you call a child pipeline, it cannot use an expression. So we have to work around that problem. And to work around that problem in this solution that I'm describing very generally, we could say option 1, we use the Azure Management API. We use a web activity. And from that management API, we pass in some body requests to that management API. We call that child pipeline. We could do that dynamically if we wish. Maybe. Option 2, we could, if we want, use logic apps. We might still need a web activity to trigger it, but within the logic apps, we can have an action that could be dynamic that we go and hit that child pipeline as well. Sure, option 2, it's fine. My preferred option, though, would be option 3, using Azure Functions. Do we like Azure Functions? Yeah, woo! Only Niall. Oh. Azure Functions are great. I like Azure Functions. I find them very flexible, very easy to develop, very nice to work with. So we complete our solution statement by saying this. Let's use metadata, of course, to drive our processing. Let's store that metadata in a SQL database, in my case. And let's use Azure Functions as the middleware to interact with those child pipelines, to give us that separation between the activities or the pipelines that we want to call from the processes that are going to call them. So if that is the solution, here is that solution developed, ready to work with, that I can introduce for you. This is not a sales pitch. This is an open source project that I created before I had children, when I had spare time. I'm hoping to do some development on it again fairly soon, but I created this framework to address that problem. A problem that, sure, we've had before with sys packages and whatever, just a problem that now exists within our Azure environment because we're using this more cloud-native technology. And by introducing this framework approach, we can do lots of other stuff, not just deal with dependencies, but we can deal with restartability. We can deal with the parallel execution. We can add email alerting. We can do other stuff here as part of this framework solution. So to give you a quick guided tour of it, I'm just going to start with the database. We're data people, right? If we can see a database diagram like this, we can understand anything. So in this database diagram, just to introduce this solution to you, I'm going to start with that pipelines table. That table that's going to include all of those, what I'm now going to call worker pipelines that we want to go and execute. Just their name, nothing complicated. We can also include an enable or disable flag on them, just to give us a bit more functionality in this processing. Around that pipelines table, we have a stages table, just like the slides when I was addressing the solution. The stages dealing with those vertical processing boundaries. So the stages of execution and then a join between them to the pipelines table. So what pipelines are going to run in what stage. I've then introduced another concept here which I call batch executions. So if you want to run something hourly, something daily, something monthly, or on whatever cadence you like, you can now do that with a batch execution, which means that you can potentially run multiple instances of this framework at the same time. If you're doing something that's hourly or daily and there's an overlap, that's fine. It can handle that. On the right-hand side there of my orangey box, there's a pipeline parameters table, and there's also a pipeline dependencies table. Now, I talked about the vertical processing boundaries of the execution stages as handling our dependencies. Absolutely. Those are the hard boundaries between the stages of execution that we want. The pipeline dependencies table is there as a soft boundary, if you like, and when we get failures and things at runtime, it can use that dependencies table to determine if we can carry on running other stuff, or we need to block downstream pipelines because there has been an upstream failure. And hopefully I'll demonstrate this for you shortly. We then say at the bottom, I'm going to offer some information that can support that worker pipeline in the form of the orchestrator where the pipeline lives, in Synapse, in Data Factory. But not just that, because we're using Azure Functions as the middleware, we can say which Azure resource group is that orchestrator in, which Azure subscription is it in, even which Azure tenant is it in. So we can reach across tenant boundaries because we're using Azure Functions to authenticate against that worker pipeline that exists downstream. So metadata there at the bottom to guide where that worker pipeline actually is in terms of our global infrastructure or whatever. And also authentication information, so we can go and hit that worker pipeline. Currently using service principals, either stored in Key Vault or directly in the database in an encrypted form, if you like. Then, just to complete this picture, at the top, we've got some metadata to drive some email alerting if we want. We don't have to. It's there. It's optional. So for every pipeline in our pipelines table, we can say for the output, did that pipeline fail, complete, success, whatever, we can subscribe to that status and get an email alert for a bunch of people or one person, as you prefer. Then on the right-hand side, we've got some tables without any relationships, just for the running of the framework. Execution log table, an error log table, the current execution table, so what's running right now in that framework, and the batch execution table. So everything in that black box on the right-hand side is just for the running of the framework at a given point. And then lastly, in the middle, a properties table that we can use to inform configuration, to tweak things, to set what we want to do in a restart scenario, in a failure scenario, how we want to handle that failure. Do we want email alerting turned on? So a properties table that exists there to support some of the configuration as part of that framework and its features. Next up, we have our Azure Functions app. So I said I like Azure Functions, and the Azure Functions that I've got as part of this open source solution, I've developed them in C# because I'm old. I'm not cool and trendy enough to use Python, so I use C#. I developed them in Visual Studio or VS Code in .NET 3.1. They could, if you like, run on a consumption tier app service plan. Microsoft give you one of these. You can get, last time I checked, about 50,000 minutes of execution for free. So we can do that with a Windows host. That's fine. We can, of course, then hit those functions using the first-class activity that now exists within Data Factory and the link service for it as well. We can, of course, interact with our key vault via managed identity, and we can call our downstream pipeline, that worker pipeline, wherever it may be. So that's what the Functions app is doing. The functions then themselves that exist. So I did something really, really crazy with my naming conventions. I called the functions by what they actually do. Radical, right? Who thought that we should ever do that? So I've got 4 functions in here, firstly, that because we can read, we understand what these do. Validation, execution, checking the pipeline status, getting the activity errors, if indeed that pipeline failed. The validation one, perhaps, is the only one I really need to explain here, because a lot of data engineers, they will run Data Factory pipelines in debug mode, and then they will include it in the framework, and they'll say, oh, the validation's failing. And they say, well, it works fine in debug mode. I say, fine, have you actually deployed it? They say, oh, no, we didn't know how to do that. It works in debug mode, though. I say, no, please deploy the pipeline. We have this sort of 2-layer interface to our Data Factory, whereby we have a debug surface, we have the deployed resource as well. So we included that validation because I was fed up of developers telling me that it worked in debug mode. They hadn't actually deployed it. So those first 4 pipelines, of course, interact and are responsible for looking after that worker in whichever Data Factory. And then the last one, sending an email, maybe via your Office 365 subscription or whatever. That's what it's there for. Optional, whether we use it or not, entirely up to you. Then when it comes to the pipelines themselves, so I've very much framed the worker pipeline here in the context of the work we want to go and do. To talk about the rest of the pipelines that we've got within this solution, so we are just calling pipelines with pipelines, I give them this hierarchy. The worker at the bottom, the grey one for completeness, that's outside of the scope of what the framework is really responsible for. That's there as the thing that we go and interact with, and it can do whatever you want. Now, the nice thing is that it means that that worker is quite nicely decoupled from the framework as well. So when you want to go and debug and do integration testing or whatever on that worker, you can do that in isolation. There's no sort of real requirement here. So that's there in this picture for completeness, and that's the thing we want to go and call. Then the hierarchy of my other pipelines, blue, green, orange, and yellow, I've got the grandparent in there as kind of a bit of an optional one as well, but included for completeness. So what I like to do in the grandparent pipeline is set up the Azure environment. Depending on what you want to do with it, maybe you want to start a cluster, scale up a service, get something turned on. There is the sort of the environment wrapper, if you like. So a little bit outside the scope, but kind of included for completeness as well. Particularly if you're using batch executions. You might want to call multiple instances of the framework from the grandparent. Entirely up to you, but kind of included really just to complete this generational hierarchy. The parent, though, is where the framework really starts, where we start figuring out what metadata we've got, what we actually need to go and run, and we then start iterating over those execution stages from that parent. The child is there to scale out. So within that execution stage, we can then scale out everything that's in there. We know there's no dependencies within that stage, so we can run all of those workers in parallel. So the child is there to use the default behavior of the Data Factory for each activity to create those 50 parallel threads, if that's what we need. And then for each parallel thread of execution, we have an infant pipeline. Maybe ironic that the infant, as the lowest level of the generational hierarchy, does the most work. Absolutely. I get all of my children to do all of my work for me now. I just tell them what to do. So the infant is there to guide, to look after the workers. So to kind of bring that to life, I've got a Vizio diagram that is, of course, impossible to read on this screen. That's fine. Let's open Vizio and have a look. Oh no, and I've forgotten to open Vizio. I'll get it open, then I'll duplicate my screen so you can see it. Do we like Vizio? Mixed response. Vizio's great. I'll show you why Vizio's great when I can find it. There we go. So in the images subdirectory of the proc framework repository, I'll duplicate shortly. It's just Vizio's thinking about opening up for me. I should have got it open first. Come on, laptop. Oh, not responding. Boo. Sorry, I should have opened this. It's worth the wait. I promise it's worth the wait. This is why we don't like Vizio, yeah, absolutely. Oh, come on, Vizio, you're making me look bad now. I've talked you up. So, again, when I had spare time, I loved Vizio. I went and created my own stencils for Vizio for all of the Azure icons. You can go and get these and play along the Azure icon game at home with your family at Christmas. They'll love you for doing that. I also created a stencil for Data Factory because I was fed up with rubbish documentation. So I created stencils for Data Factory and included SVGs of all of the activities. So you could go and create good documentation of your Data Factory pipelines, which you all do, right? Yes, Paul. So the framework. Here it is. Somebody did some good documentation on it. And I'm not going to go through every single activity. That would be really boring. But to give you, again, a whistle-stop tour of what's in here, the green parent pipeline with its green background, we set up the framework. We check if the framework is already running. We use the Azure Management API to do that. So if there's an instance of the framework already running for a particular batch execution, we don't do it again. Seems obvious, right? We do some metadata integrity checks. Not integrity checks in terms of those primary and foreign keys that I'd got in the database, but if we think about those execution stages, is there an execution stage that doesn't have pipelines enabled within it? The database will do some preliminary checks for you as part of its running of the framework. It will try and do a cleanup process. Because we are quite tightly coupling our Data Factory with our Azure Functions, with our SQL database here, there could always be wider Azure platform failures. Not that Microsoft would ever confess to that, but there could be, which means that the database, the metadata, might end up in a slightly inconsistent state compared to what Data Factory has actually done. So if that occurs, the framework will try and recover, and it will try and check the actual status of a pipeline compared to the database and get it back to a recoverable state for us. We go over to the right-hand side. We get those execution stages just as a distinct list of IDs, basically, and we pass it that first for each activity as a sequential for each activity that will just go and iterate on those execution stages. We then hit that child pipeline. We then go into our second level for each. This one will scale out. It will execute a batch of 50 by default, and it will get those worker pipelines within that execution stage. For each worker pipeline that we want to run, we have the worker executor, which goes into the infant. The infant hits the database, it gets information about the worker, the subscription, the tenant, the resource group, etc., the credentials it's going to use to authenticate when it calls out to it. We validate to make sure the engineers have actually deployed it. We then go ahead, assuming it's there, we update the logs, we get some parameters that we might want to pass to that worker, and we execute. Now, the idea of these Azure Functions is to be fairly asynchronous in what they do. So we're not going to execute that worker and sit and wait for it. As soon as it's queued and in progress, this function will return. And as soon as that function is returned, because we don't really want it to be durable, because that can get expensive, so we try and deal with some of the cost of a quick result from that function. We then use Data Factory to iterate using an until activity to get that worker status on a timed iteration that we can control from the properties table. And then as soon as that worker pipeline has returned a valid status of complete or failed or whatever, we go forward, we update the database. In the scenario of a failed status, we can get those activity details as the error information that's actually come from the pipeline. On success, fine, whatever. We go forward, we complete, we get any alerting metadata that may exist, and we send some emails if that's required. So we have one infant execution per worker doing all of those things there to look after it. We've scaled out using those infants for the execution stage. They complete, we come back in, we start the next execution stage, and we carry on. So to show you this in action, I've got the metadata database here. I've got the current execution table. Let's zoom it on the go, because ASCII is getting on a bit now. So we'll use zoom it for his poor old eyes. He's not listening to me. And in here, I've got a Data Factory pipeline. I was running the demo earlier just to make sure we were good. So I'm going to run this parent. Now, this is not particularly demo-friendly because of all the things that this is doing and going through, of course, but we'll try and cover off what you want to see based on the time that we've got remaining in this session. So I've triggered that parent. As a side note, if you are doing something in debug mode and you're using a for each activity and you want it to scale out, if that for each activity contains a call child pipeline activity, in debug mode it will not scale out. There's a limitation of the debug mode that it will force you to do it sequentially. So I'm just triggering this because I want that parallelism. So I trigger, my parent starts kicking off, it checks if it's already running or not, which of course it isn't, and we can sort of see those executions, that metadata integrity and things happening. We can flip to the database, we can look at the current execution table, I can keep hitting the refresh key. As you may have seen on Twitter yesterday, I was famously quoted saying the more times you hit the refresh button, the faster it will go. Absolutely true. We are making the internet faster by doing this. There's obviously some other information in here, but let's just try and clean it up a little bit for the purposes of demos. I put my commas at the end of my attributes, by the way. You feel free to judge me for that. But we start then preparing that first execution stage. And you'll notice that I've got some very simple worker pipelines in here that are called wait 1, 2, 3, 4, 5. They just contain a wait activity that is actually parameterized, so I'm just passing something to it. So dummy worker pipelines just for the purposes of this demo. You'll notice I've also got a pipeline called intentional error. Guess what that's going to do? So those first 4 pipelines, they're all running in parallel. I've got the status, I've got the information, I've got the pipeline run ID in the metadata database and the parameters that are being passed to it. So I've got some successes coming through. I could flip back to the Data Factory Studio and have a look in here if I want, have a look at those pipeline runs. So you'll see my intentional error pipeline has failed, very intentionally. We can equally hit refresh in here as well. This will also make it go faster, just like Management Studio. What I've done is for that until activity, for that wait within there, I've dialed it right down to 5 seconds. So it'll try and keep checking as quickly as possible to try and make this demo friendly. But the main thing I wanted to show you, if that intentional error has now failed, which it has, if I just come back to this metadata, you'll see that stage 1 set of pipelines with that failure status. Then what I've done is I've got the failure handling behavior enabled to use that dependency metadata as well. So you'll notice now that actually for stage 2, if we just stick a box around the stage 2 pipelines, pipelines ID 6 and 7 have been blocked. So the framework will look ahead to the next execution stage, and it will say, oh, actually, there's a dependency here. So it will block those downstream pipelines, but then based on what I've got configured, it will still try and process everything else that does exist. So pipelines ID 5 and 8, in this case, it will still try and run them. So it does still try and be helpful. And because we've got this metadata to support our execution, we get that support, we get that help, if you like. So those two are preparing. You'll notice now that actually for stage 3, the framework has looked ahead again. It's now blocked the next pipeline because it knows again that there's a dependency here. So although we have those hard dependency boundaries for our execution stages, we can have some metadata that will support the status of it, which means that if possible, we could still complete here, or still run everything that you possibly can if there isn't a dependency chain. Now, absolutely, we could make the argument that, well, why have you got a pipeline in stage 2 if it has no dependencies? Why don't you just put it all in stage 1 and parallelize it there? Sure, absolutely. This is just how this metadata is structured. Again, just really for demo purposes. So while that's going through the motions, and we can kind of just come back in here as well, we can hit refresh a few more times. I can show you the properties table. So things that I've got configured. The restart behavior, we can choose to override it if we wish. We don't always have to restart from the point of failure. We could just say override and do everything again. We don't care about that last execution. Let's just truncate it. Things like our workers, if they get cancelled, we decide how we want that to behave and how we want to deal with it. That email alerting, and we've got a HTML bit of markdown here for the body of that email that we might want to send. I've got this idea of a precursor stored procedure, which in this case is just the demo mode one that I've created to help me out when running this. But if we want the metadata set up in a particular way, we want to do something a little more dynamic at runtime, maybe it's Sunday at 11 o'clock or something, we could do that as part of the SQL database. What I can also show you is the error log table. So for my intentional error pipeline, the exact activity failure messages that get captured via Data Factory Studio, that get activity error function that I had in place, it inputs the same, it puts that same information into the database for you. Fun fact, Microsoft tell you in their documentation that the error code attribute that you get from an activity is an integer data type, except when it isn't. All good fun. So this is pretty much wrapping up now, or at least it should be. My parent pipeline should now have completed, albeit with a failure, because of course the final outcome of everything that's in that execution, it didn't run successfully. So if I wanted to, if I was being lazy, or if I was just an operational team, I could just simply rerun that parent. And the framework will deal with that. It will recover. My intentional error pipeline, it is self-healing. Your pipelines might not do this, but my one's special. Special for demo purposes, of course. So my parent will rerun. It'll do its usual bits and pieces, and its setup, and it's checking the metadata, etc., etc. I'm not going to go through the whole thing again, but really, all I just want to demonstrate is that failure status and those blocked pipelines that we did have, they're now going to get cleared out for that second try. That second try for this particular batch execution, it could be. We can wrap this up however we want. Structuring this metadata could then potentially become the new hardest problem in how you structure your pipelines. So there we go. It's just cleared out that failure status. It's left, of course, all of the ones that succeeded in place. That's all good. I should give them a green, shouldn't I? There we go. Green for good. They succeeded. It's going to rerun the ones that failed. So we're not going to go through all of that, but I'm sure you get the idea. And because I've got, I think, 5 minutes or so left, yeah? 4 minutes, sorry, 4 minutes. I can just go back to the slides and we can just kind of finish up here. So we've seen the demo, we get the idea, but why do this? Well, to go further with that problem, and not just that simplistic problem statement and that simplistic demo, what I would like to introduce for you as well is what I've called this hub and spoke integration architecture. So because I like drawing pictures, I tell my family that my job is just coloring in and drawing. This is a solution, obviously not the actual solution, but a logical representation of a solution that I delivered for a customer. They had 25 locations all around the world that they wanted to ingest data from. And we had kind of an Azure or a Microsoft landing zone architecture, if you want to call it that as well. We had particular Azure regions that were aligned to what they used with their express routes and things. And we had them in South Africa, South Australia, South America, East US, etc. So we had all of these data factories for their 4 environments. And this hub and spoke, we've got these landing zones as the hubs, if you like. We've got self-hosted integration runtimes at those sites that exist. We bring all of that data in to the landing zone, and we then take it forward into a data warehouse, if we want to call it that, a lake house, sure. We're not worried about those terms today, but the orchestration principles were there. Raw data comes into the landing zones, into those regions. We then had pipelines that would curate that data to take them forward, to do the enrichment, to get the insight from that data. All of this process globally was orchestrated using that framework that I just showed you. So it required a few tweaks and scaling up and scaling out those functions and those services a little more than what I showed you in my demo, absolutely. But this was made possible. It was made possible to do this on a UTC time zone. So for all of these data factories, and some of them were actually in different Azure tenants as well, we could orchestrate all of this to take it forward into this ultimate data warehouse for what they needed to do. All good fun. So the art of the possible, and obviously a bit of a journey in how we get there. Again, not new problems, not really new concepts, just new technology that we use to do them. So with that, folks, thank you very much for listening. Here's my contact information. There's also a QR code for it, and I'd very much appreciate your feedback via that SQL Bits QR code on the right-hand side there as well. Thank you.